Welcome back. This video will be discussing forces on a truss. Those linear forces we can talk about in terms of compression and tension. So let's get started. We have already completed building our bridge. We built it over in the room 110, the makerspace. And now we're coming back into the design area to evaluate our current bridge that we worked on together as a group. Right now, I'm currently working on this bridge right here. But I'm going to go ahead and go through the process of opening up a new one. Now keep in mind, this has changed. The visual nature of this has changed some. But what was new, save, and open used to be over here. But now it's a little bit more interactive and a little bit better, in my opinion. We're going to go to open. We're going to ask which one we're going to open up. And again, what we had before is the same thing right here. We're just going to go ahead and locate what we want to have open and available to us. Once we do that, and we're in the engineering tab, we're going to go ahead and take a look at the bridge that we were building. Specifically, the trusses. This truss right here will be the same truss that you and your partner have built. So whatever bridge design that was, that's what you should have open. This one for me, again, happens to be my 3rd hour Würzburger first bridge that I created. Yours will be individual to you. So let's get started on those linear forces, compression and tension. And anytime we want to take a look at this, we're going to go ahead and have to add a load to it. So what just showed up on your main screen right there could be the concrete as part of the roadbed. It could be the vehicles and the pedestrian traffic. It could be a train. It could be the railroad tracks that the train rides on. All those types of things that the truss needs to support. So that weight or that total load can be located or found right here. So 200 newtons is being placed as a load on top of our truss. When we take a look at that, this is kind of the breakdown of it. The load per truss, because we have 2 trusses, is only 100 newtons. We identified right here, because we've tested this bridge on Whitebox Learning, that our maximum capacity is 225.26 newtons on my particular bridge. Now, to get a little context, I'm going to break away from Whitebox Learning, and I'm going to go ahead and check how many newtons equal a pound, or vice versa. If 1 pound equals how many newtons? In this case, I'm going to go ahead and put down 1. 1 newton. How many pounds do we think that would be? It's close to 1/4 of a pound. 0.25 would be 1/4 of a pound. 0.5 would be 1/2 a pound. We are actually less than 1/4 of a pound. So let's take a look at that. Right now, on our bridge, each truss is carrying 22.28 pounds currently. What our Whitebox Learning told us was on my bridge, my truss was capable of carrying, when built to spec with a high level of quality control, a maximum of 50.80 pounds. That's each truss. If I were to build my bridge out of 1/8 inch balsa using extremely high quality building techniques and having a high level of quality control, I would have a bridge that would be capable of holding up just slightly over 100 pounds based on the trusses alone. Let's go back here. What we're looking to do today is we're going to be identifying what parts of the bridge over here, what part of these web members are going to be stressed or strained the most. And we're going to be able to identify that using this eye right here. Once I click on that, you'll notice that this key of information shows up. Anything that's towards the middle, where it has 0, 0, 0, has virtually no stress or strain on the web members or the joints that connect those. What we are going to do is we're going to actually increase this number. I'm going to go to 300 and apply it. Please note, all of a sudden now, instead of being the yellows and the really light oranges, we're starting to go into the darker oranges and the lighter greens. Please note, when things are starting to have arrows associated with them in a certain color, that's indicating or being indicated up here in this key. We're going to go ahead and change this again. As we do this, we can start to see the stress and strain starting to act on our bridge. Up in this area right here, we have compression starting to happen. The darker orange is starting to be compressed, while down near the bottom, tension, where it's trying to be ripped apart or pulled apart, is starting to happen. Pushed together, pulled apart. Compression, tension. Now anywhere we locate the bright red or the bright blue, that's an indicator of maximum yield, where our bridge will no longer be able to support that level of total load. This portion right here. So we're going to go ahead and take this all the way up to 800 newtons. Once we do that, we have now indicated all the way out to our maximum blue range and all the way out to our maximum red range. At this point, you can take your bridge, your three-dimensionally created bridge, and I want you to use the blue and the red markers to indicate, based on a number that I'm going to give you here, at 600 newtons, what does your bridge look like? If I were doing this, I would be identifying my middle area here as my dark blues, and I would be indicating my middle area on the top of my truss as my reds. I would also indicate each one of these as being red, here as well, and the same things over here. Also note that this vertical would be in blue, as well as this one here. Make sure that you color code the appropriate web members as you see them here. For those students or groups that have indicated 600 as too large of a number, where everything is blue or everything is red, there's no distinguishing anywhere, you can reduce your number to 500. In my case, what this might look like is if I put 1,000 up here, nearly everything is blue and nearly everything is red. If this assists you and helps you determine which members are in compression and which ones are in tension, you can do so. I simply use 600 as a middle number that would help most students. Again, please note, if any of this becomes a little bit too challenging, there's too much information being shown, you simply get rid of the visuals and open up just what you want to see. And remember, anytime you make an adjustment, you always have to hit apply. Again, as a note, this number right here, 200 newtons, is too small of a number for me to indicate any of my blues or any of my reds. Please determine a number that is suitable on your bridge that will stress and strain your web members to get them to a red and a dark blue scenario. Please note, this part right here, red-blue analysis, to indicate your compression or tension on your bridge is one of those final items to be completed.